Hello and welcome to lesson 2.5 Common Sense. Um, let's dive in. This is 2.5. Okay, so the graphs of f of x and g of x, right? So we see we have an exponential function and a logarithmic function, right? So it says to um, make a list of the characteristics of each function. Okay, so for characteristics, let's talk about whether or not they are increasing or decreasing. So f of x is 10 of x, so right, so this is this one right here. Okay, so then increasing or decreasing. What do we think? Okay, so it should be increasing, right? That's kind of the first thing we talk about. Then let's talk about the domain. So domain is my x values, right? That's domain, my x values. So this graph will go on forever and ever on the left, and it's going to go up forever and ever, right? All the way. So my domain here is all real numbers. So x is equal to all real numbers. You can also say it, domain is all real numbers. Or you can say negative infinity to positive infinity, right? Different ways of writing this, okay? Now, what about the range? So the range is my y coordinates, right? So my smallest value here is 0. So my range goes from 0 and my maximum value is going to be infinity, right? Because this goes on forever and ever and ever and ever, okay? You can also say this that y is greater than 0, okay? Let's talk about the y-intercepts or any intercepts, right? So intercepts. So here there's a y-intercept. So there's a y-intercept, and that is going to be right there at 0, comma 1. Okay. Now let's talk about asymptotes. So asymptote. Okay. There's a horizontal asymptote. So there's a horizontal asymptote at this right here, right? This is the line, the imaginary line. There's an asymptote there. So that is y equals 0, okay? This is y equals 0. Nice. Now let's switch colors to talk about log of x, okay? So again, this is log of x. Is it increasing or decreasing? So we see we're going up, we're going up, we're going up. So it's an increasing function. Increasing function, okay? Domain. Domain is x. So what is the smallest x value? 0, right? So it's 0 up into infinity, okay? Or you can say that x is greater than 0, okay? Not equal to 0, just greater than 0. Now what about my range? What's the smallest this will ever go? It's going to go down, 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 right? Forever and ever. So we'll call that negative infinity, up to infinity, right? Which again is the same thing as saying that it's y is equal to all real numbers. So the range is all real numbers. Okay. Let's talk about intercepts now. So intercepts. Do we have a y-intercept? So the answer there is no, right? It it never really touches it. Okay, this graph is not the best, but it never touches it. But there is an x-intercept, right? It does cross it. It never crosses. It crosses here, and that is at. So I will say that there's an x-intercept at 0, sorry, at 1, comma 0. Okay, so we'll label this point. This one is 1, comma 0, and then the y-intercept here is 0, comma 1. Okay, and now let's talk about our asymptote. So asymptote. Do we have a vertical or a horizontal asymptote? So in this case, we have a vertical one. Okay, so there's a vertical asymptote at x is equal to 0. Okay, so it's important to know that a vertical asymptotes have the equation x equals something. Okay, horizontal asymptotes have the equation y equals something. Okay, awesome. Let's talk about the next part. Each question below refers to the graphs of the functions 10, f of x, and g of x, right? So there's two functions. State whether they are true or false. If they are false, correct the statement so that it is true. Okay. So every graph of the function g of x equals log of x will contain the point 1, comma 0. So let's look at 1, comma 0. So right there we know that's a true statement. Okay. We can see this also if I were to plug it in. So I have log base 10 of 1 is equal to 0. That's a true statement, right? I know that if I were to do 10 to what power is equal to 1. That question mark is equal to 0. Okay. Yeah, that's another important thing that I didn't say. So log here, if there's no base here, no number, we assume it's 10. Okay, we assume it's base 10. Both graphs have vertical asymptotes. That is false, right? False. So both graphs both have asymptotes. Yes, that's correct. But what? But f of x equals 10 to the x has a horizontal asymptote, and then g of x is equal to log of x has a vertical asymptote. Okay. The graphs of f of x and g of x have the same rate of change. So rate of change, this is an interesting word, it's an interesting concept, but what does it mean? It means, think about what happens as x increases. So as x increases here, we're on this roller coaster. We're on this roller coaster for f of x. And as x goes up, we're going super, super, super fast, right? We are increasing at a faster rate of change. Okay? Now here, we're going a little bit slower, right? We are being more slow with our traveling, right? So this is false. False. Okay? F of x and g of x have different rates of change. Different rates of change. Okay? The functions are inverses of each other. That is true. Okay? We know that that's true. So 10 to the x and log of x are inverses. Okay? We saw that a little bit here, that it's a reflection over the line y equals x. Okay, so visually and graphically, you can see it here, okay? To some extent. This is the line y equals x. Okay? We'll talk about this in question in 7. So the range of f of x, so the range for f of x was that y was greater than 0. But let's do 0 to infinity. Is a domain of g of x. So for g of x, the domain there is 0 to infinity, right? 0 to infinity. This is another true statement, okay? That's also true. Now for 8, the graph of g of x will never reach 3. So then g of x is equal to log of x, right? So we'll never reach 3. That means that 3 is equal to log of x. Let's think about that. How would I solve for that? So I can rearrange this, right? And take 10 to the power of that, right? So we can isolate it. So this gets rid of this. So 10 cubed is equal to x. So I get that x is equal to 1000. Okay. So that this is false, right? The graph. So the graph g of x will reach 3. Okay. Now number 9. So we're in the set part. Okay, ready, set. Solve each equation. Write each answer as a logarithm and a decimal approximation. Okay. So to solve these exponential equations, so these are exponential equations. Exponential equations. You want to get rid of this, okay? How do I get rid of it? I have to take the log, okay? Because they're inverses of each other. So I take log of base 10 here. What I do to one side, I do to the other. It's one of those commandments, okay? So what I do to one side, I do to the other. This will cancel it out. What did I do? This goes away. So I'm left with x is equal to log base 10 of 0.1, okay? Now, let's do this without a calculator. So if x is equal to this, I want to think about 10 to what power is equal to 0.1. So to see this better, I want to rewrite this 10 question mark is equal to 1/10, right? I rewrote this as a fraction. Now I know that this 10 question mark is equal to 10 to the negative 1. So then my question mark here is equal to negative 1. So this x is equal to negative 1. Okay? Now we can go ahead and solve for that in a calculator. So where's my handy dandy? Where is it? Oh, not there. So we're going to talk about log of 0.1. That's negative 1. Okay? So my my answer would be negative 1. So it was right there. Okay? Same thing here, right? I want to take the log. So take a log. Take the log of both sides. So log and log. This cancels it out. So I'm left with x minus 3 is equal to log of 202. Now I need to solve for x. So solving for x here, I add 3 plus 3. So I'm left with x is equal to log of 202 plus 3. Okay, let's, what is this? So now let's do log of 202 plus 3. I get 5.305. So we went around to, let's do 3 decimals. Okay. For 11, again, you want to isolate the exponential. Okay, so what do I mean by that? I want to have this by itself first. Okay, so I want to add 53. Add 53, 53. So I get 10 to the x plus 5 is equal to negative 71. Okay. Now I can take the log. Log here. So then this becomes x plus 5 is equal to log of negative 71. And we need to pause here. Does this exist? So log of negative 71 does not exist. Okay? Because the domain for a log, so domain of log is 0 to infinity. Okay, so here it's not in my domain. Okay, so this right here has no solution. No solution. No solution. Okay, so this entire problem has no solution. Okay, so let's highlight this is here, this is here, this is that one. This is no solution. Okay. Now, let's double check that. How do I know I'm not lying? So log of negative 71, enter. There's not a real answer, okay? So there's no real answer. You cannot have a negative, a log of a negative, okay? It does not exist. Here, for 12, we have this fraction, okay? We're all gonna get scared. No, we're not, right? We're not gonna get scared. We know how to do that. I wanna get rid of this fraction. So I wanna multiply both sides by 3. So now I'm left with 10 to the 2x minus 1 is equal to 225. Okay. Now, just make this clear. This is to the power up here, right? Okay. Now I take the log of both sides. So now I'm left with 2x minus 1 is equal to log of 225. Okay. Now, the rest kind of falls through, right? How do I solve for x now? I add plus 1 on both sides. So I get 2x is equal to log of 225 plus 1. I divide this by 2 at the very end, right? So I get that x is equal to log of 225 plus 1 all over 2. Okay? You can write this as like 1/2 log of 225 plus 1. Okay? And now let's kind of put this into our calculator. So I'm going to have log 225 plus 1. I should have put parentheses earlier. Dividing this by 2. 1.676. Okay, 1.676. So x equal to 1.676. So this is an exact answer. This is a decimal approximation. Okay. 13. Still very similar here, right? We want to solve and isolate this first, right? So we want to have this by itself. So I subtract 3 on both sides. So I get 4, 10 to the x minus 2 is equal to 2018. 2018, okay? I divide both sides by 4, divide by 4. And I'm left with 10 to the x minus 2 is equal to, let's think about that. That's 504.5. How did I do that? Let's do my fraction, my division house. This goes 5 times 20, 0, 1, 0. 8, 4, right? So 4 and 16, 2.0.5. So 504.5, okay? Now, I can take a log here because I isolated the exponential. So now I'm left with x minus 2 is equal to log of 504.5. Last step, I simply just add 2. Okay, so x is equal to log of 504.5 plus 2. Let's go. 504.5 plus 2. That is 4.703. 4.703. So x is 4.703. Okay? This is my exact answer, and this is my decimal approximation. Okay? 14. So what is up with 14? What are we doing there? This is an exponential, right? So they are the exact same base. So they have the same base. So they have the same base. So we've done this before, that if they have the same base, you set the exponents equal to each other. Set exponents equal. Okay? So I'm going to be left with 5x is equal to 2x minus 7. And then solve for x. So 3x is equal to negative 7. X is equal to negative 7/3, which is equal to negative 2.33. Repeating. Okay? I could have done this differently too. I could have taken logs, right? It's going to be the exact same answer, right? So I can take a log of both sides. So I take log, goes away, right? So I'm left with 5x is equal to 2x minus 7, which is what I got over here. Okay, cool. Solve the following system of equations. Okay, so y is equal to 10 to the power of x, and y is equal to 0.001. So system of equations, I want to have an x and a y. Okay, this is what I want. So let's think about this a little bit. So what this means is that if I tell you that, let's say if I tell you Hershey's is equal to Oreo, and then if I tell you that Hershey's is equal to milk, then what I'm saying here is that milk is equal to Oreo, right? Because Hershey's equals Oreo, and if Hershey's equals milk, then if both of those things are equal to each other, then milk is equal to Oreo. Okay? I love Hershey's and I love Oreo and I love milk and Oreos. So for 15, I'm telling you that y is equal to 10 to the x. So y is equal to 10 to the x. And that also has to be equal to 0.001. That's also y. So y equals 10 to the x, which is equal to another version of y. So then let's kind of clean this up so I can solve for x. Okay? And now, let's just solve for x now, right? So I can take the log of both sides here. So I'm left with x is equal to log of 0.001. Okay? That's my x, and I know my y. My y is just this. It's an actual number. Okay? But this is equal to what? So let's think about this. This can be thought of as 10 to what power is equal to 0.001. So let's rewrite this as a fraction. So 10 question mark is equal to 1 over 10 100,000 to 1,000. Okay? So then how can I think about this power? So 10 to the power of 0 is 1, 10 squared is 10, sorry, 10 to the power of 2 is 100, 10 cubed is 1,000. So this is 10 question mark is equal to 1 over 10 cubed. So then 10 question mark is equal to 10 to the negative 3. So then question mark is equal to negative 3. Okay, cool. So again, this is some work. This is some thinking. It depends on what we're asking you for. If I gave you a calculator, you can easily plug in as log of 0.001, and that's equal to negative 3. Okay. but you should feel comfortable doing both ways, and you should kind of strive to do your best to not have a calculator, okay? For at least some of these parts. I'm gonna try to make this move a little bit over here. Okay, 16. So same concept here. So I have y is equal to this function, and then y is equal to this, okay? So I'm gonna set them equal to each other first, right? That's kind of my first instinct. 10 to the x minus 5 is equal to negative 1 half x minus 4. Now, what is going on, right? We're a little bit on uncharted territory. We haven't really done this, I would say, on these problems before, right? We've been solving pretty directly, but this is going to throw a curveball at us. Let's just kind of solve. Let's isolate stuff. So we have 10 to the x is equal to negative 1 half x. I add 5, I add 5. This is plus 1, okay? So I know this equation. I love this equation. We know about this one. And then I also know that this is a line. So algebraically, I'm not going to teach you how to do that algebraically. There's really no way to do it algebraically besides plugging and chugging numbers, okay? I don't want us to do that. So at this point in time, we can graph both of these. This is one equation. This is equation 1. Equation 1, equation 2, right? So let's go ahead and graph those. So let's go to our calculator. 10x, 10 to the power of x, right? 10 to the power of x is equal to negative 1 half x plus 1. So let's see. What is that? What is it? So this is my 10 to the x, and this is my line, okay? I want to find this intersection point. So to do that, I'm going to go to second, calculate, and what does 5 say? Intersect. So we're going to go to intersect, right? So click intersect. My left bound, just click somewhere on the left. My right bound, click on the right. So right there. So that intersection right there is at 0. X equals 0. So what I just solved for is for x. So x is equal to 0. Now what's going to be y? So x is equal to 0 from my intersection. So then y is going to be equal to 10 to 0 minus 5. So 1 minus 5 is equal to negative 4. So in this point right here is 0, comma, negative 4. Okay? So again, I graphed them. Okay? Let's try to graphing them from the very beginning. So let's graph both of them. Let's do 10 to the x minus 5. And then what else do I have? And I have the same one. I shouldn't have it. Negative 1 half x minus 4. Okay? So now I have a whole different graph here, right? Two different graphs. Let's go ahead and second trace, right? Intersect. My left bound, where's this? My left bound, I need to put it on the left of this, of these two, right? So my right bound is right there. So my intersection right there for x is at 0. So that's my intersection, 0. So x is equal to 0, and my intersection here is negative 4. So it gives you the answer, okay? So different ways of doing this, okay? Two different ways. I hope that made a little bit of sense. These are a little bit more challenging, I would say, to think about, essentially. 17, same concept. So I'm going to set them equal to each other. 10x minus 3 is equal to negative 3x plus 10. I'm going to add 3. So 10x is equal to negative 3x plus 13. Now I can just graph this, right? So graph. So use graph. Use, not graphing, use graphs. Use graph. Okay. So for here, let's go. We have 10x, 10 to the power of x, and then we have negative 3x plus 13. Okay, so we see that. I want to find my intersection point. Second, calculate, intersect my left bound here, My right bound is going to be there. So that intersection is at x equals 1. So that's my intersection. So then x is equal to 1 from intersection. Okay, so you get that by doing second trace. Let's do second trace intersect. Okay, so if you need help with that, you can also do a quick Google search about how to find the intersection, okay? Or just let me know. So x is equals to 1, and then we can plug it in. So then we know that y is equal to 10 to the 1 minus 3. So y is equal to 10 minus 3, which is equal to 7, okay? So then this point right here is 1 comma 7. Now, just to show it, let's go ahead and graph this entirely, Brent, like 10 to the power of x minus 3, and then we have, well, I keep forgetting, negative 3x, oops, negative 3x minus 10, no graph, okay? And then let's go to second calculate, let's go to intersect.
Calculator error makes solving math.
Oh my goodness, I apologize. Skip video. So we are there and there. So that does not work to a half. Oh, it's plus 10. Plus 10. Okay, graphing them again. Rerunning the same process. I hope you all are experts on this by now. Right. So my point right there is 1 comma 7. Okay. So 1 comma 7. That's my answer. So this is 1 point, another point here. What was my answer here? Did I not write it? So this was negative 3.001. Okay, this is my other one. Okay, cool. Now we are going into the Go section, right? So we should be pretty familiar with these. Use long division to divide the following problems. This is what we did earlier, well, what I did earlier. Write your answers as a quotient and a remainder. Show each step. So we're going to show each step, show all of our work. That's important. So let's think about this. 9 goes into 2 how many times? 0. 9 goes into 21 how many times? The most it can go is 2. So that's 18. Right, you multiply them out. Then we subtract them. 3, bring down to 7. 9 goes into 37 about 4 times, right? No more. There's 1, bring down this 9. 9 goes into 19 2 times, that's 18. 1. This is my remainder, so remainder 1. Okay? Let's do 12. So 12 goes into 3 0 times. 12 goes into 38 3 times, so that's 36. This is 2, bring down the 2 here. 12 goes into 22 just 1 time, right? 1 times 12 is 12. Subtract them, and you get 10. This is your remainder, so remainder 10. Cool. Now we're at 20. We're over here at number 20. So 24 goes into 46 exactly. Not exactly, but about 1 time only, just once. It's 24, and then subtract them. So this is 2. This is 2. Bring down this 1. Now let's think about it. 24 times, let's do 9 times 4 is 36, 18. Perfect. So it goes in 9 times. So this is 216. So my remainder here is 5, right? So it's 19, remainder 5. Now 21. 13 goes into 4 0 times. 13 goes into 42 about 3 times, right? 13 times 3 is 39. And then this is 3. Bring down this 9. So this is 3 again. This is 39. 0. Bring down the 7. 13 goes into 7 0 times, and 0, and then 7 again. Remainder 7. Okay? So this is where we're at. Now 11 goes into 1 0 times. 11 goes into 15 1 times. 11 is 4. Bring down to 7. This is 4 again, so this is 44. So this is 3. We're down at 9. 11 times 3 is 33. 6. That's my remainder. Remainder 6. Okay. And last but not least, 62 goes into 9 0 times. 62 goes into 98 just 1 time, no more, because if you were to go into 2, it would be about 120 some, which we'll go over. This is 62 right here. Subtract them. This is going to be 6, and this is 3. Bring down this 8 right here. Now we're at 368. So let's think about 60 times 5. So 62 times 5. Let's think about that. 10, 30, 31. Let's try going a little bit higher. 12, 36, 37. We bust, right? So we can't do that. We need to go low. So then we are at 310. Subtract them. We're at 8, 5. Bring down the last 5 here. 62 goes into 585. Let's go big. Let's do like 9, 8, 1, 54, 55. So, right, it can go 10 times that, 620. It has to go in 9 times, so we're at 558. Subtract these out now. 7, 15, borrow a cup of sugar. 7 minus 5 is 2. So this is my remainder, right? So remainder 27. Okay. So these last ones, pretty straightforward. We're doing a long division. Make sure you practice and make sure you know how to do that. It helps a lot sometimes. These system of equations, right? So you're trying to solve for both x and y. I set them equal to each other. I graph them, right? So I did these graphically. Graphically, we'll call them graphically. Okay. Everything else here, I take the log of both sides, right? So you want to isolate the exponential and then you take the log. Okay. I hope that was a little bit of common sense, as the lesson name states, okay?